This week on the show, we have why ZFS is doing file system checksumming right. We also cover better TMPFS throughput performance on DragonFlyBSD. We also have a blog post about reshaping pools with ZFS, a package source experiment on Manjaro AH64 Pinebook-pro Linux, as well as a central log host with syslog-ng tutorial on FreeBSD, as well as other interesting things in this week's episode of BSD Now. BSD Now, episode 340, Check My Sums. Recorded for the 4th of March 2020. Hello, I'm your host, Benedict Reuschling.
And I'm Alan Jude.
Yeah, welcome back to this episode, and glad to have you listening to us, like on the road or wherever you might be. We have great headlines for you as always, so we jump right into the first one that we have. It's from Mariusz Zaborski, who was guest host once here, and he keeps blogging, so this time he has checksumming in file systems and why ZFS is doing it right.
So he says, one of the best aspects of ZFS is its reliability. This can be accomplished using a few features like its copy-on-write approach and checksumming. Today, we will look at how ZFS does checksumming and why it does it the best way. Most of the file systems don't provide any integrity checking and fail in several scenarios. For example, data bit flips. So when data that we wanted to store ends up with a bit or more flipped on the hard drive or by the cables, or somehow the wrong data is stored on the hard drive. So there's a couple different ways that can happen. Something can be faulty and the data gets corrupted before we write it. It can get corrupted while it's being written, like by the cables or by the controller or something like that. Or it could be just over time, something happens, and when we read the data back, we get back different data than we wrote to the drive. That's the main thing that ZFS checksumming is meant to solve. By checksumming it before we send it for the write, and then checksumming it after the read, we can make sure that we got back the data the way we wrote it to the disk in the first place. The next is what is called a misdirected write. Sometimes, especially with buggy HBAs or RAID controllers, the data you asked the system to write to the hard drive at sector number X actually gets written to some other sector number, which causes two problems. A, when you try to read the data, you read back whatever happens to be at sector X instead of what the data you expected to be there. And the second problem is wherever else it ended up writing your data, it probably overwrote some other bit of data. So now, if you do a ZFS scrub, ZFS would detect two problems. The data that got overwritten with your data, and so therefore isn't the right data for that sector, and the current sector isn't it doesn't contain the data that it's supposed to, because you never actually wrote there. So misdirected writes can be a big thing, and you can also just have a misdirected read. Something goes wrong with the head, and the hard drive doesn't read the sector you asked it for, it reads some other sector. ZFS can detect that and be like, hey, what's going on there? You can also have phantom writes, and that's when a write operation never made it to the disk. So you told the hard drive to write, the hard drive claimed that it had done the writing, but it actually hadn't. This can happen a lot, especially in virtual machines, where the hypervisor will fake the response, where the hard drive say, yes, I finished this write, when it really hasn't, in order to make the VM faster. And usually it's fine because the write eventually does get completed, but if the power fails at the wrong time, you can end up having written data or think you've written the data, but it actually hasn't gotten written. And again, ZFS can detect that and deal with it. So checksumming may help us detect errors in a few other situations. But before jumping further into ZFS, let's look at how checksumming could be implemented in a similar manner for other file systems, and what problems it addresses and which it does not. As an example, we will use NetApp's waffle or write anywhere file layout. And it's a feature called block checksumming, or BCS. In BCS, the hard drives are formatted with 520 byte sectors. A lot of standard hard drives support having 520 byte sectors instead of 512 byte sectors for encrypted disks, and they will use that extra 8 bytes to store the authentication code to be able to know that the data hasn't been modified since it was encrypted. But in this case, you could also use it to store a checksum. The operating system still saw the disk as 512 bytes per sector, but when the data for the sector is read, Waffle will read the checksum as well and verify that. This approach helps us detect those bit flips we were talking about when the wrong data is read or written to the disk, and the checksum allows us to verify that. But what about the other problems, those misdirected reads and writes and so on? Unfortunately, this approach does not solve those. If the sector was read from a different place than we wanted, it's going to read the checksum of that wrong sector, and that checksum is probably going to be right. And suddenly, you asked it to read file A, and it actually gave you data from file B. And the checksum was right, so it didn't notice an error. Or in the misdirected write case, it ends up overwriting part of file B with the data you meant to write to file A. And then when you go to read file B, there's no problem detected except for a chunk of your data has been overwritten with some other file. And that's no good. But yeah, so if data was misdirected, or there's a phantom write, or the hard drive only pretend to store the data or whatever, there's no way to detect such behavior. So the block checksum approach is better than not checksumming at all, but it only really helps with the bit flips or bit rot kind of bugs. It doesn't actually solve as many of the problems as the ZFS approach does. ZFS, like always, decided to go with a different approach. The structure that ZFS is using is called a Merkle tree. Each node has a checksum of all of its child nodes. So in ZFS, at the very top, you have what's called the Uber block. It's basically like a super block in UFS, but stronger, so hence Uber block. And it basically just has the checksums of its children, which are the next level blocks. And those contain pointers to other blocks and have their checksums, and all the way down until you get down to data blocks that contain just data. So in a normal file layout in ZFS, if you have a small file, it will have the metadata and then a pointer to the data. And the metadata will have like file name and will know the checksum of the data. If you have a really big file, you can end up with more levels of indirection, where you'd have, you have the file block and it points to like a level 3 block that points to an array of level 2 blocks, and each of those has the checksum and an array of level 1 blocks, and the level 1 blocks then know about a bunch of level 0 blocks that are the actual data. So if you have a many gigabyte file, you can use the ZDB ZFS debugger to actually see that structure and see how it all works. But for every record in ZFS, you have the checksum. And so by default, files will be broken up into 128K chunks, and you'll have a checksum of each 128K chunk, although you can use bigger or smaller record sizes to your heart's content, I guess. Marius has a diagram here you can look at. And if you want to know more about it, Kirk did a really good job of explaining it in the design and implementation of the FreeBSD operating system textbook. Anyway, the above image is a little bit simplified, but should give you an idea of how data is organized in ZFS. The checksum of the block is not stored with the data. So that data block, the level 0 block, doesn't contain the checksum. Some metadata block that points to it does. And that will get written somewhere else. And that way, the checksum and the data are not stored in the same place, so a misdirected write won't put both of those in the same place. And so we will notice that it's messed up. And every block is checksummed by its parent all the way to the very top. And even that very top one is checksummed, but it's checksummed by the label of the pool itself. And that's how, when ZFS is, when you're doing the import at boot, what ZFS does is goes through every Uber block and finds the newest one where the checksum matches. Because one that was in the process of being written when the power went out, the checksum won't have been updated yet and it'll be wrong. And so it'll go back one transaction group older than that, and it'll find the best Uber block. Anyway, the checksum goes all the way up to the top to the Uber block, which keeps the checksum of all of its leaves. And this is quite simplified because the Uber block keeps only one checksum for the object set, which keeps the checksum of the rest of the D nodes, and on and on. Anyway, thanks to that, we can detect any flip bits, and the checksums will not match the stored data because the checksum was stored with the metadata somewhere else. Also, we can detect misdirected reads if there is a bit flip on offset, the checksum will not match that read data. Because the data was read from the wrong offset, the checksum will have been either from the right offset or a different wrong offset and will be for still different data and will detect that that's an error. Or the other way around, and so on. If there was a partial or phantom read, the checksum will not match, and we will try again or go to redundancy or whatever. We can see that using a Merkle tree is a very safe way to store data on the disk, as it allows us to detect a lot of problems in the system. It's also worth noting that if ZFS is configured in a redundant way, it will detect broken data and correct that data and repair it, and therefore it becomes self-healing.
Yeah, because most file systems can detect data, but they cannot fix it. But ZFS can.
A lot of them can't detect, like they're not going to detect data corruption. They can detect if their metadata doesn't make sense. And that's where you get, FSCK and check disk and things like that. Those are mostly detecting, hey, my index says there's a file over here and that file never actually got written, or, the file's 0 bytes because we created the file, started writing it, but we never finished, so I never updated its size. And things like that. And it will detect those. Or like, I found a directory over here, but it's not linked into the tree somewhere. What do you want me to do with it? And it can deal with that kind of thing. But most file systems don't have any checksums. UFS is in the process of growing, I think it's cylinder group checksums or something, to add a little bit of its ability to detect when things happen. And like when Apple made APFS, they do checksums, but only on the metadata, not on the actual data. So again, they can detect when something goes wrong with the file system, but they don't detect when something goes wrong with the data.
Okay, yeah, definitely a nice write-up. Do you know if Marius did those drawings by himself, or did he use a tool for that?
They're kind of funny in the way that they're just wobbly enough. They look hand-drawn, but they might actually be a tool that's meant to be looking like it's hand-drawn.
Yeah, I think there is such a tool. Maybe someone knows from our listeners and can send this to us, because I'm fairly sure this is...
I've used ASCII flow to draw stuff like that. In ASCII, it lets you just like drag and make boxes of ASCII art and so on, and resize them and so on. But yeah, I don't know what tool he was using.
Okay, well, I guess we'll find the answer. So yes, Marius, thank for that blog post, and I guess people should also comment and how they like that and if they found it useful. All right, next up is an update on DragonFlyBSD, which has improved its TMPFS implementation for better throughput performance, and this is covered by Pharonix. So they write there that it's been a while since having any new magical optimizations to talk about by DragonFlyBSD lead developer Matt Dillon. But on Wednesday, that's February 13, he landed some significant temporary file system TMPFS optimizations for better throughput, including with swap. Of several interesting commits merged tonight, the improved write clustering is a big one. In particular, quote, reduces low memory TMPFS paging I/O overheads by 4 times and generally increases paging throughput to SSD-based swap by 2 to 4 times. TMPFS is now able to issue a lot more 64 kilobyte I/Os when under memory pressure, unquote.
So I'm guessing that's instead of 4K I/Os, and yes, that would make a big difference.
Oh yeah. There's also a new tunable in the VM space, as well as part of this commit on Wednesday night. This follows a lot of recent work on desynth, improved paged out daemon pipelining, and other routine work. This work is building up towards the eventual Dragonfly 5.8 version, while those wanting to try the latest improvements right away can find their daily snapshots.
Yeah, I know MJG at FreeBSD did a lot of work on TMPFS on FreeBSD, mostly around the locking, I think, because it's used heavily in Poudre and so on for the package building. And especially with a lot of CPUs, reducing that lock contention meant we get those packages built quicker.
Yeah, everyone is happy about that. The fresher the packages and the sooner they arrive, the better. So yeah, I think DragonFlyBSD is also making improvements. And if you're a DragonFlyBSD user who sees improvements with that or in a certain workload, then let us know. We'll be always happy to get more news from DragonFlyBSD. All right, time for News Roundup in this episode. We have an article from Chris Seibenman, yet again, why ZFS is not good at growing and reshaping pools or shrinking them.
thanks to Chris for writing this up. And he goes, I recently read Mark McBride's 5 years of BTRFS.
Is it ButterFS? B3FS?
Better have a backup FS. Anyway, it has significant discussion of why McBride chose to use BTRFS over ZFS, and it boils down to ZFS not being very good at evolving your pool structure. Basically, ZFS is pretty much only good at growing, and growing in certain ways, and not so good at reshaping. Yes. And I can talk about a little bit why that is if this article doesn't cover it as in-depth as I would like to. Anyway, you might doubt this judgment from a ButterFS user, but let me say, as both a fan of ZFS and a long-term user of it, that this is unfortunately quite true. ZFS is not a good choice if you want to modify your pool disk layout significantly over time. ZFS works best if the only changes to your pool is replacing drives with bigger drives. So in the ZFS environment at the University of Toronto here, we go to quite some lengths to be able to expand pools incrementally over time. And while this works, it both leaves us with unbalanced pools and means that we're basically forced to use mirroring instead of RAID Z. And he explains, an unbalanced pool is one where some VDEVs in disk have much more data than others. This is less of an issue for us now that we're using SSDs instead of hard drives. It depends on your workload how big of an issue it is. At Scale Engine for our video archive machines, we started out with 24 drives, and then we added 24 more, and then we added 44 more. And yeah, so if you have a pool that's like 70% full, it's a bunch of VDEVs, and each of them are about 70% full, and then you add a bunch of new VDEVs, those new VDEVs are 0% full. And so when you do reads, they're all going to come from the old VDEV. When you do writes, most of it, not all of it, most of it's going to end up going to the more empty pool VDEVs. So when you do reads, you're going to read mostly from the empty VDEVs and maybe a little bit from the other VDEVs, and it won't be very balanced. Now, if you don't need more performance than what just the new VDEVs provides, it's not that big of a deal. But obviously being balanced would be slightly better, as it would give all of the disks would be doing work when you're trying to read instead of just some of them. You might sensibly ask why ZFS is not good at this, despite being many years old, and people have had this issue with ZFS for a long time. One fundamental reason is that ZFS is philosophically and practically opposed to rewriting existing data on disk. Once data is written, it wants everything to be completely immutable, apart from copying it to a replacement disk, more or less. So this mostly has to do with the layout and what we talked about last week with the DVA, or data virtual address. So in ZFS, when you write data, it gets allocated to a place on a VDEV, and it knows, all right, that data is on this VDEV at this data virtual address. And you can't change that without rewriting, say, all of the metadata to change where that is. So that's why you see the kind of gymnastics that we use with the ZFS device removal, the ability to shrink a pool. What that ends up doing is just saying, hey, for VDEV that you want to remove, this chunk of it, which will be just a range saying, the first 100 gigs of that are now rewritten over here. And the next 10 gigs are over here, and the next 40 gigs are over there. And it just has this remapping table of as big of ranges as it could create of the data from the old VDEV is now over here. So when you remove a VDEV with device removal, it basically stays around as a virtual VDEV that just says, for any block you try to pick, that block is now over here on some other disk. And eventually, as you overwrite that data, those mappings go away, and that table takes up less room. And that's why when we did the VDEV expansion work, which isn't finished yet, but the prototype is there, it ends up, if you have your columns, like 1, 2, 3, 4 disks, and you're adding the fifth one, then what we have to do is keep those 4, then go find the fifth block, which is actually back on the second row of the first column, and move that over, and then slide everything over, and just keep sliding your data over so that the block that was at address 100 is not still at the new address 100, even though the layout changed. And it mostly has to do with the fact that you don't go back and rewrite all of the metadata to point to different addresses. And the main reason for that is that increases the chance of something going wrong. It's copy on write, but you want to make sure that the data is always correct. So there's been talk about different ways to solve that. you could have a level of indirection where all the DVAs are actually virtual and you keep this remapping table and we can move stuff around, but that's pretty icky. It was one of the approaches we looked at for the shingled magnetic drives, because you need to be able to pick up a whole region, which I think on most of the drives was 256 megabytes at a time, and rewrite it or move it to a different location. And you would basically say, hey, that 256 meg region of that drive is now over here because we had to do the SMR gymnastics and so on. Anyway, that's why it's difficult in ZFS. It depends on your workload how big of a deal it really is. But anyway, Chris goes on. But any sort of restructuring or rebalancing of a storage pool, whether it's ZFS or ButterFS or whatever, necessarily involves shifting data around. Data that used to live on this disk must be rewritten and live somewhere else on that disk or some other disk. And all of this has to be kept track of directly or indirectly. It's rather difficult to have immutable data that is on a mutable storage layout. In the grand tradition of computer science, we can sort of solve this problem with a layer of indirection. That's that table thing I was just talking about, where the top layer stays immutable, but the bottom layer mutates. This is awkward and doesn't entirely satisfy either side, but as I mentioned, that's how the device removal stuff works, is by having this indirection table that gets added. But that takes a bit of memory, not that much though, but a bit of memory, and it sticks around for a long time until you've overwritten all that data. This is also the simpler approach for ZFS to take. Not having to support reshaping your storage requires less code and less design. For instance, you don't have to figure out how to reliably keep track of how far along the reshaping process is. And that's something that we have to do for the RAID Z expansion. If you have a RAID Z4 of 4 disks and you're expanding it to 5 disks, you have to keep track of how far through that you are. Because when you want to read, like if you're 10% through of a terabyte, if you're trying to read from the first 100 gigabytes that have been reshaped, then you have to include the 5th disk in your math of where sector 100 lives. But if you're reading the part you haven't remapped yet, then you don't want to include the 5th disk in your math of figuring out what offsets it's at. And it gets complicated.
Oh yeah, very quickly.
Less code also means less bugs, and bugs in reshaping operations can be catastrophic, right? ZFS doesn't want to lose your data, so it doesn't want to go rewriting it for no reason. Since ZFS was not designed to support any sort of reshaping, adding it would be a lot of work in both design and code and raise a lot of questions, which is a good part of why no one has really tackled this in all the years that ZFS has been around. In particular, there's been talk about this idea of the block pointer rewrite feature, which would be able to go back and update all the block pointers to point to new DVAs and so on. The biggest issue is, in our estimation, that would be the last feature ever added to ZFS, because it would make adding any new feature after it so complicated to make sure we got it right that it just wouldn't be worth it. Happy for someone to prove us wrong, but it's difficult. Anyway, the official party line of ZFS's design is more or less what you should get your storage right in the first time around, and then maybe you can grow it. Or to put it another way, that ZFS was designed for locally attached storage where you start out with a fully configured system rather than incrementally expanding capacity over time. Again, it depends on how big of a deal the unbalanced LUN thing is. In general, it's not a huge deal, but it can lead to some weird performance and so on. Anyway, he says, this is an aspect of how ZFS is not a universal file system. Just as ZFS is not good for all workloads, it's not necessarily good for all usage patterns or growth or system evolutions. But, it's worked for me in the cases, even as I've taken a system that started out with 12 disks and then grew it to 24 disks and then grew it to 40 disks and then grew it to like 144 disks. But that was mostly an archival use case, so the performance demand wasn't that bad. And it can really depend on your data churn rate. If data's getting overwritten a lot, then if you have unbalanced LUNs, they'll very quickly even out. But if you have data that never gets modified, it's going to stay unbalanced for a long time, unless you manually rebalance it using send receive, but you don't really want to be doing that on a frequent basis.
Probably not, yeah. But yeah, important considerations to make, and you should know about ZFS's growing and shrinking before putting it into production. All right, so that's yet another great article, and we should continue with our next item, which is using package source on Manjaro Linux AH64 Pinebook-pro. So on this more Linux-centric blog, I would say, is basically running an experiment, how far they would go with package source. And they write that I wanted to see how package source works on ARch64 Linux Manjaro, since it is a very mature framework that is very portable and supported by many architectures. Package source is a package framework or package management system for Unix-like operating systems. It was forked from the FreeBSD ports collection in 1997 as the primary package management system for NetBSD. And one might question why use package source on Arch-based Manjaro, since the Pacman package repository is very good at its own. I see alternative package source as a good automated build framework that offers a way to reproduce or to produce independent build environment /user/package that does not interfere with the current Linux distribution in any way, since all libraries are statically built. So here they have used the latest Manjaro for Pinebook-pro and the standard recommended tools as mentioned in their wiki. And so it's GCC, ncurses, zlib, and OpenSSL. So next, we make sure that they have at least 10 GB of disk space available, or use 20 gigs for package source to place the package source environment there. Then we have a choice to use either the stable quarterly branches of package source or the bleeding edge current, which contains the latest pieces of software, but can be unstable in certain situations and times of sync. If one decides to experiment with the current, like me, you can always get help from the wonderful NetBSD/package source community on their mailing lists. So this is you can find those on netbsd.org/mailing lists. Okay, so you download package source current from their FTP. That's pretty straightforward and described in the blog post if you want to know how. Next, they will bootstrap package source on the Manjaro Linux ARch64 so that they can start building packages. So this is going to use a package source /bootstrap and then running ./bootstrap. This will take about 10 minutes to finish. And once done, we're almost ready to start building packages. There will be a new system-independent environment created by default in user/package. Like if one wishes to change the location and customize, one can do so by reading the package source documentation, but they didn't choose to here. The package directory structure is built accordingly. And all the package executable binaries are stored in /user/package/bin. And this should be taken into an account if setting up a new binary executable path. There's a caveat in Linux Manjaro ARch64, which results on the dreaded message during certain package builds, like builds should fail with compiler cannot create executables. But they also have the fix for that. In order to fix this, you have to edit the user package source /mk/termcap.builtin.mk and replace all built-in _libname.termcap equals values with curses. So there's a diff available on the blog as well, so you can just apply that. And so now, up to the first installed packages. What package are they using first? The first test was to see if Doom 3, package source /game/dhewm3 builds and runs on Manjaro ARch64, and it does. Although it's not using the Panfrost drivers for now, but it's Doom at least. Why is Doom always the test? It's like, okay. Installing binary packages. So in the directory from the last section, there's a subdirectory called all, which contains all the binary packages that are available for the platform, excluding those that may not be distributed via FTP or CD-ROM. To install those packages directly from an FTP, run the following command with like setting a path first and then point it at the NetBSD CDN. So after all these preparations are done, you can install a package like LibreOffice, which is big, so you better get it this way. And they note that any prerequisite packages needed to run the package in question will be installed too, assuming they are present when you install from. So they show how to do that. And it seems like they have updated the blog posts and have set up their package in repo by now. So I guess they're kind of fond of package source now. So they also show how to do that and how to use it. So yeah, this is seems like a successful test of plugging a package source into a Linux distribution.
Yeah, package source is meant to be portable and used anywhere.
Yeah, so it's not limited to the BSDs only, or it's also on other systems as well. Even macOS does have it, so there's plenty of other systems that can use it. All right, then next we have a central log host with syslog-ng on FreeBSD for you, which is a tutorial.
If you have any up-to-date FreeBSD system, like version 11 or 12, and grab syslog-ng, then you can set up a logging host. So this post will assume that the log host has IP address 10.20.30.101. You should use the RFC example IPs, otherwise Lucas will yell at you. Anyway, the log host logs any syslog messages for 1 week, only with separate log file for each weekday, and each log file is overwritten after a week. Please bear in mind that other configurations are, of course, possible. This is just what they're using. And the hosts which log to the log host are using the standard FreeBSD syslog daemon. So you're only using syslog-ng on the machine that you're aggregating the logs on. So on your log machine, you'll want to install syslog-ng, disable the default syslog, and enable syslog-ng instead. And then edit the syslog-ng.conf and get that set up. And then start syslog-ng. And then you can edit its config and configure the log host to say, log to this address. And then you can set up your log rotation. So they're setting up their different weekday files in the config file. And then saying any source this, filter it, and then set the destination. And then it's set. Then in your standard FreeBSD client that's using the default syslog, FreeBSD syslog-d, then you just, in your syslog.conf, say log everything to the IP of the log host. And all your machines will then send their logs to the log host, which will then aggregate them and put them all in those weekday files.
Nice.
Then they have a part 2, which expands on it a little bit, including, in this case, they want to look for things like look for failing hard drives or daemons which are not configured correctly, or daemons which are not behaving correctly, or disks or volumes that are filling up, or bad requests to the web server or mail server, and things like that. So in this one, they're installing logcheck and logtail 2, and then they are creating a script to do the checking and send an email. So they have the output directory, the output file, the mail recipient, and the mail subject. And then it will basically start grepping through those logs, tailing them and grepping them, and sending out emails when it finds something in the logs that looks alarming. So, for example, they have a regex in here that finds failed disks and emails you about them, basically. And this way, you have all your machines send their logs to the logging host, and then the logging host can look at those logs and say, hey, there's a failing drive over here. You might want to check that out.
Yeah, always look at your logs. They will tell you many things. If you don't look at them, you will just be, everything is fine. Yes, so time for Beastie Bits now. We have the FreeBSD at LinuxConf 2020 session videos now online, all of them. So you can see what talks were given and some of the people who gave them.
Yep, and we have FreeBSD, the other Unix-like operating system, FreeBSD Beehive intro, how an Australian infrastructure as a service company uses FreeBSD, improving the FreeBSD security advisory process, introduction to FreeBSD ports, 25 years and counting, the Linux Professional Institute and BSD working together, and the ZFS file system. Want to watch most of those and just need to find time.
Yeah, I watched the one from Philip, and I liked it, although he couldn't finish. Of course, ZFS is such a big topic. You cannot do this one in an hour, but he got a pretty good introduction done. So if you haven't heard about or used ZFS before, it's a good start. So yeah, next item here is unlock your laptop with your phone. Ooh. So this is over at Vermidon's blog.
Yeah, and he says, I really do not like the smart card ecosystem, probably because it's a big pain in the ass to set up each subsystem on FreeBSD to make it lock and unlock your laptop with a smart card. And, not to mention, it will be possible because the lack of drivers and laptop built-in smart card readers and so on and so on. Some people use fingerprint readers for fast workstation or laptop unlocking, but it's the same case there. Maybe the drivers don't work. It's kind of annoying. But you can also unlock your Unix laptop with your phone by just attaching it to your device. And this is where FreeBSD's DevD subsystem can come in handy. Today, I'll show you how to unlock your laptop using your phone.
Which is cool.
Yeah, so they basically set up some matching to see when your phone gets plugged in via USB and looking for your phone specific serial number. And then you can have it do things like start up the screensaver or unlock the machine. So in this example, they say, whenever a USB device is attached that has this vendor ID, this product ID, and this specific serial number, then kill the screensaver and restart the screensaver, and that will unlock the machine. And then they have a detach, says when you unplug the phone, then you want to run the screensaver command lock, and it will automatically lock the laptop as soon as you unplug the phone. That's interesting. And then it actually has an improved version at the bottom where he uses the unlock command instead of just killing the screensaver program. So this one is literally just looking for a device with a specific serial number and using that to lock and unlock your machine. I'm sure there's other ways you could do it with the two-factor auth stuff as well. But that is an interesting approach and does provide you the basics that you want of just getting it locking and unlocking easily.
Yeah, and you kind of can say, oh, magically I walk to my laptop and it unlocks, or I walk away and it locks. So, yeah. Especially if you're in like a conference place and just want to make sure that when you go to the bathroom, your screen is locked. Cool. That's fairly nice and easy to set up with not many commands to run. So thanks, Vermiden, for this yet another desktop blog post in your continuing series of blog posts.
Yes, I think that's part 20 of the series. So if you use FreeBSD on desktop, I definitely recommend flipping through there because I'm sure there's something you will find useful in there somewhere.
I've been reading through them and have found a couple of things that I will implement on my company laptop, which is running FreeBSD. Okay, next item, back to package source. Managing a database of vulnerabilities for a package system, the package source study. This is a presentation from ETA SEC 20, which was held in Ancona, Italy.
Yes, so they want to basically maintain a text file full of known vulnerabilities, which is basically a three-tuple of the package name, the type of exploit, and the URL to the CVE. And so they want to say, any Samba greater than 4.0 but less than 4.11.5 has an out-of-bounds read, and here's the link for the CVE. And that way, when you go to install something, you can check against it and say, hey, there's a problem.
Yeah, cool.
Yeah, it's interesting to look through this because, in FreeBSD, we have the VU XML thing, and it's got some scalability issues and so on, but generally seems to work. It's interesting for other projects to talk about how they do it, where we could maybe learn something.
And then we have our usual list of, or reminders of user groups and bugs. The one from Hamilton BSD user group on March 10th is a reminder.
Yes, my user group will be having our second meeting Tuesday, March 10th at 6:30 at the Boston Pizza, the same place as last time. So if you're anywhere near Hamilton in Southern Ontario, do come out. We're hoping to break our record number of attendees when we do that. Yeah,
show up.
Next up, we have the Charm Bug meeting. So if you're in Maryland or the DC area, Charmbug will be having their meeting Tuesday, March 24th at 7 p.m. And that one will be a talk by my friend Ash Gokul, who will be talking about SPI ROM retromacy, or how my hardware hides software that runs the hardware. So this one will be a look at the interesting hardware vulnerabilities and general distrust of firmware as provided by specific vendors in recent years. In certain cases, vulnerabilities can be found in low-level EEPROMs that have raised the question of what software is actually embedded in our hardware. So Ash will be walking through some interesting examples of specific hardware hacking that he has performed and will share his experience with how he found things on various devices. His talk will also touch on some BSD ports that you might want to try, but will be a general discussion about hardware hacking relevant to the general security audience, not just BSD users. And they will be meeting at a meetup location called Unallocated Space.
Cool.
Which is at 512 Shaw Court in Severn, Maryland.
Okay, yeah, that's that's a good location for computer people to meet. Excellent. If you have a BSD user group of your own and want us to mention it a couple weeks before the next meeting, then send this to us at feedback@bsdnow.tv, and then it will appear in the show, which might let a couple more people show up. You never know.
Yes. Also, when you're doing that, if you want to send us notes from your last meeting about, what interesting things came up or anything like that, we'd love to hear that too.
Oh yes, like how it went, what kind of people you met, or what kind of topics you discussed. It's all interesting for people who might think, I could do that same thing in my community or in my place. So you never know who's listening, especially on this episode. Time for feedback and questions now. We have people sending us questions, sometimes a little less than we want, but now we have a good list of those. But we have a couple of travels coming up, so we build a backlog here. If you have a question for us, anything BSD related or ZFS maybe, but not limited to that, send this to feedback@bsdnow.tv and we'll have it in a future episode. The first one who did this was Andrew, and ZFS feature flags is his question. Andrew writes, "Hi Alan and Benedict, a few ZFS things. I recently upgraded my pool on FreeBSD 12.1 and noticed the large _G node feature was added. Looking at the OpenZFS feature flags wiki page, it's out of date. I made an account wanting to contribute and update, but it was unable to propose an update."
I think accounts have to be approved by the admin because of some problem with spam bots we've been having. So you might need to just send an email to the admin being like, "Here's my username, can you please approve me?" Or join the OpenZFS Slack channel.
Okay, so the zpool features is also, or isn't updated. The one I think I'll try my hand at submitting a patch sometime this week. Yeah, good. Submitting.
So you mean the man page in FreeBSD or in upstream OpenZFS?
Oh yes, since that is pulled down from upstream, right? This is not our own.
Well, no. Martin Matuska rewrote the FreeBSD man page in the time between the end of OpenSolaris and before OpenZFS or something.
Yeah.
And so it's not really related. And basically, when we pull in new features, we have to remember to copy and paste sections and rewrite the markup into mandoc. And so, yes, it is a problem where features sometimes don't make it into the man page properly
For the local system.
Yeah. Hopefully that'll be fixed soon. At the hackathon we had back in November, somebody I think succeeded in splitting up the man pages for the ZFS and zpool commands into separate man page for each subcommand. And so if those were rewritten in the nice the mandoc format, then we will be in very good stead to be able to just switch to those instead.
But I like Andrew's approach that he wants to submit a patch and contribute this way to an update.
For sure. Ideally, we'd like to get in sync with upstream so this stops happening. Because yes, I noticed the large G node feature is in fact missing from our copy of that man page.
So his one small question, do we have any ETA on RAID Z expansion, as in rough ETA down to the year it might land, 2020, 2021?
So there's a pull request open for it on the OpenZFS or the ZFS on Linux repo in GitHub. It explains what isn't finished yet and what is. So basically it needs some testing and the rest of the work finished. And right now, Matt's kind of busy. He also has 2 small children. So entirely impossible to say when it might be done. The answer is, when Matt gets around to it or when someone else steps up and does some of the work. I expect, like many things, if someone started doing some of the work, Matt would suddenly get more interested again. But I don't know.
Yeah, but most parts are finished, right? It's not that it's half-baked or it's still in the test phase.
Yeah, so definitely only recommend using it on test pools, but there is a version you can try.
That's all we know. Yeah, so thanks for that question, and thanks for the show feedback. Next is Sam with TwinCat BSD as a topic or subject. Sam writes, new TC/BSD based on FreeBSD from Backoff Automation. Yes, I remember this. So they have the news article linked here. On page 4, it says that in their Backoff news overview, so Backoff Automation is I think, industrial automation company, if I'm not mistaken. Yeah. And they're using BSD on one of their embedded systems.
Yeah. And so you can choose to run TwinCat/BSD, which is based on FreeBSD, on all of their industrial automation stuff.
And yes, there's also a video where they have the time code where they mention this. So
yeah, well, it's good to see companies that are using BSD actually talking about the fact that they're using it rather than just keeping it a secret.
And they can do that because the BSD license allows that, and it's not any problem with legalese things that are typically done with other licenses that are less company friendly, let's say. Yeah, so thanks for that pointer, Sam. And if you have other company news, we will also have this in the episode in a future one, maybe.
Yeah, we've never really done it here, but I remember on the old Linux podcasts that I helped out with once, they had a Runs Linux segment at the beginning of the show or whatever, where they would just have, some thing that they found that runs Linux that they might not have expected to. And we've covered a bunch of those, like when people have found BSD in their car dash or in their washing machine or in their TV. But
yeah, running strings on binaries is always interesting what comes up. Sometimes unexpectedly, but yeah, nevertheless interesting. Okay, thanks Sam for that. And next and last is Dacian with FreeBSD plus AMD GPU plus Lenovo E595 question. That goes like this. Dear Benedict and Alan, first of all, thank you for your effort in creating the podcast. Oh, yes, thank you. It's not just us, there are also people behind the scenes that are not in the limelight as often. But yeah, thank you. It is extremely helpful, packed with lots of info and gathering the BSD community in one place. I became interested in FreeBSD half a year ago, and since then I have converted all my CentOS virtual machines into jails and Beehive VMs like Samba, Mini DLNA, Music PD, Unified Controller, Transmission Server, OpenVPN, and Pi-hole into Debian and Beehive. Fantastic and elegant. I love it. Wow, this seems like a big-scale migration here. Wow. Cool. To get to the point of this message, I have a Lenovo E595 specifically bought to run Linux. But soon after I bought it, I became interested in FreeBSD. This particular laptop has an AMD Ryzen 5 and GPU Radeon Vega 8. I do have really hard time to make AMD GPU driver to be recognized in FreeBSD and did not find any info specifically for my level of understanding to make this running. So after a week or so, I found one reference on the FreeBSD current mailing list, but this goes beyond my understanding, and I wouldn't use FreeBSD 13 for production. If you or the listeners could point me to the right direction, that would be much appreciated.
Yeah, I've never tried to use an AMD card on a FreeBSD machine in a while. It looks like this is a one-line patch to do something with some related. Looks like they have a So at the bottom, they have a small patch for the DRM devel kmod port that would then build that patch into the newer driver. Those the instructions at the bottom of that email applied to FreeBSD 12.1 should do the same thing and maybe fix the problem for you. Although I don't know how old that message is. I would assume by now they would have updated the port to solve this problem. I don't know when the last time they updated the DRM devel ports is, though.
Yep. Could you try with maybe a live CD and get the port to just load the driver?
Well, the point of the message is that there's apparently a bug in the driver code and you need a newer version of the driver, and I don't know if that's actually in the ports tree yet.
Yeah, okay. Because otherwise I would have thought you would have gotten one of the 13 snapshots to see whether that's been fixed. Maybe someone else knows and can write this solution to us so we connect the people. Or just wait a little bit longer until this hits the tree and will be available for everyone. Because I'm fairly sure as more people get Ryzen laptops, they will, and the GPUs as well.
Yeah, well, waiting isn't a great solution, but yes.
Yeah, if the patch is there already, it might just take a while to trickle down the the tree.
The patch is from October, though, so I don't know.
Oh, okay. Yeah, that should have materialized by now. Or there's something else that needs to be done.
Well, there might be a reason why it's not the right solution. I don't know.
Yeah. Maybe the X11 folks would know?
Maybe.
Could be. We're out of the loop. We don't know. We don't have that hardware. But if anyone else is listening who has that and has solved it, we would be happy to connect you. Okay, so this is it for this episode. I hope you found it interesting. As always, send us feedback to BSD Now at bsdnow.tv. No, feedback at bsdnow.tv. And yes, you can listen to us every week at the same time, usually Thursdays or Friday mornings when this comes out, at least in my time. And hope you enjoy your BSD experience, and wherever you're listening to us, thank you for joining us.
Yes, and see you next time.